Avanti Conveyors provides the corrugated board industry with highly automated materials handling systems aimed at increasing the factory's profitability. This presentation briefly describes our development of a mathematical simulation tool to help corrugated box plants increase efficiency and improve overall equipment effectiveness. Mathematically, the production of stacks of boards or palletized cases is a discrete event dynamic system which can be modeled by simulation. This involves the construction of an event-driven computer model that represents the whole production line or system driven by actual or enhanced production data. Factory simulation has been available for over 2 decades and has been used to great effect to improve airport baggage handling, distribution centre efficiency and to reduce Disney World queues. But it has previously been too expensive for our industry to justify. Now, Avanti Conveyors have developed a standard model specifically for corrugated box plants, making it possible to produce individual client models and actual factory layouts at a fraction of past costs. For simplicity and speed of development, we use the plant's CAD factory layout drawing to visualize the simulation in 2 dimensions or 3D. If a drawing does not exist, then our own experienced conveyor designers will measure the plant and produce the drawing. This diagram shows a factory which has used simulation to improve stack throughput. Each of the machine and conveyor modules has been modelled to predict the performance based on stack width, length, height, weight, flute, blank area and required process. Mathematical models have been created for most strappers, stretch wrappers, pallet inserters, stackers, converting machines and corrugators. Our simulation models are driven by production data in an Excel spreadsheet, so the client plant's own plan schedules are used and their own machine standards. Transferring this data from your Kiwi, CBS, OMP or PC Stop system is normally straightforward. In our model, the stack rates can easily be increased so that bottlenecks can be rapidly detected. This is by setup parameters in the Excel spreadsheet. Each machine and conveyor unit has its own performance parameters and mathematical model. For machines on which an operator has to carry out a function, then this is modelled as an aid function, which can include tea and toilet breaks. Here is the simulation of a finished goods system of a box factory with flexifolder gluers and rotary die cutters, running well at 130 stacks per hour. In fact, it is running too well. This is a simple model without the normal stoppages. Here is the same factory with the central palletizer running slow, a strapper that keeps breaking down, and 2 fork truck drivers gone round the back to have a cigarette. The output is reduced right down to 40 stacks per hour. One of the key purposes of a simulation can be to evaluate the effectiveness of capital investments. To achieve this, mathematical results are necessary. Here we can see the data displayed at the top left showing the buffer usage and general flow. The results can also be visualized through the Excel charts. This one has the input and output as well as strapping and wrapping information. This data display is programmed using the function TLI programming language and can be changed to suit individual requirements. Often solutions to increase overall equipment effectiveness can simply be seen by the movement of loads through and before bottlenecks in the model. Here the pink stacks show the effect of adding sheet sales on top of high flow rates of stacks of finished cases. This video shows a before example of a box plant which in practice bottlenecked at 40 stacks an hour. There were so many stoppages that the client could not easily see which the most significant causes were. First we modelled the existing system and verified it in the factory and then studied the model. This pie graph is an example of one of the data output methods and shows the utilization for one of the transfer cars. You can see in yellow that it was blocked for 15% of its time, That is, it could not discharge its loads due to materials handling blockages. After improvements had been made to the conveyors and controls, the car was blocked for only 4% of its time. The other parts of the pie show the travelling time at 50%, the loading and unloading time at 18%, and the idle time in blue at 18%. This data clearly tells you that if you had to improve this car's performance, then increasing the speed to reduce the travelling time would have the greatest effect. After studying various scenarios, we established the causes and proposed changes. The effect was dramatic, and the throughput increased to over 150 stacks per hour. Here are some other results. In the before situation, machine number 3 was held up for 46% of the time by the handling system. In the after data, the utilization is nearly 100%. This means that the handling system did not hold up the production at all. Simulation can dramatically show the effect of random machine failures and the reduction in throughput due to problems, and it is particularly useful to evaluate planned capital investments. Advanced proof of the success of proposed investments is vital if you wish to avoid spending money solving the wrong problem. Discrete event simulation has enabled Avanti to evaluate the performance of both total systems and individual machines to provide the optimum designs and controls. Often the change necessary to give over 20% increases in throughput has been a simple insertion of 1 or 2 conveying zones, or even just the control method adjusted. Avanti Conveyors has already modelled many corrugated factories, and most have already had the chance to check before and after results to verify the simulations. Avanti's simulation development is continuing with a highly visual 3D simulator for sales visualizations and a visual physics model to allow full bench testing of PLC and computer control software before installing a system. The latter is dramatically reducing on-site commissioning time and labour and improving customer training. Avanti offer the simulation service to all factories and territories, and the package can include all or any of the following: the model, a full report, improvement suggestions, the simulation software, model operation training, and model programming. This allows a range of products from solving one problem only to equipping the client to create his own models and continually solve problems and improve OEE. If you feel that you are not getting sufficient performance from your existing equipment or need to verify a proposed capital investment, then Avanti have the solution.